Hey kids, welcome back to some more science, some more kitchen chemistry science. Kitchen chemistry science is cool. This is our last kitchen chemistry science video. Boo hoo hoo. We have a lot of other science topics to cover, so this will be the last one. So far in our kitchen chemistry videos, we looked at all the different ways that we can use chemistry to either make our foods or to cause reactions when we put different food items together. In our last video today, we are going to take a look at starches. We are going to talk about what is a starch. We are going to do some experiments with starch. We're going to do a little cooking demonstration experiment type things with starch that you can actually cook at home or just watch on the video. And lastly, we are going to use starches to do a hands-on experiment making ooblek, which is a kind of a starchy, goopy kind of concoction. It's super fun to play with. So let's get started learning about our last kitchen chemistry topic, starches. Starches are cool and science is cool. I have here in front of me 4 commonly found kinds of starch. The most common by far is this one, cornstarch. It comes from, you guessed it, corn. You take corn and get the starch out, looks like that. It's a white powder, almost like baby powder. Ugh, it feels really like it's a drying agent, so it kind of sticks to your fingers. The second most common kind of starch possibly found might be a tie between these two. This is potato starch, and it also is a white powder. And this is tapioca pearls. This one comes from potatoes, obviously. This is tapioca, it comes from the cassava root, which kind of looks like a potato. This final starch is called arrowroot, and it is, you guessed it, another white powder that comes from the arrowroot plant, which, you guessed it, looks a lot like a potato. So, you may wonder, what do you do with this stuff? Does it taste good? I don't think so. Ugh, no, doesn't taste good. So it's not a sweetener. We can't turn it into butter or cheese. It's not sugar, it's not flour. What's it for? Here to tell you that starch is used to absorb liquid. The most common use of starches in cooking is as a thickener. If you want to make a thick, creamy soup, put in some starch. If you're making a stir fry and you want to make a delicious sauce that sticks to all your vegetables and possibly meat if you have meat, you use a thickener. If you're making a cherry pie and your cherries are kind of really juicy and you don't want them soaking into your crust, you want it to be kind of a nice thick cherry filling, you use a starch. Now, sometimes it's added to foods like powdered sugar or baking powder as an anti-caking agent. So when those things sit in your cupboard, keeps the moisture out so that when you go to get your powdered sugar out, you don't have a big glob. Now, which starch you use depends on the application. Actually, flour can be used as a starch too. For the most part, I use this one, but some people might prefer this one. Or when I do pies, for some reason, I use this one. It's called for in the recipe. So the science behind starches is that starch particles are really, really tiny. And when they come in contact with the liquid, they soak the liquid up. Next, if you heat that mess, it soaks up even more. So starch in liquid can make like a paste, but when you heat it, that's when the real thickening happens. I'd like to do an experiment. We're gonna make some chocolate pudding. We're gonna do it 2 times. We're gonna make one batch without heating it, just put it in a bowl with all the ingredients. We're gonna do a second batch where we heat it, and we're gonna see which one is yummier. Let's give it a try. Science experiment time. If you want to do this experiment, go ahead and take a screenshot of this recipe and print it out. All right, for the first part of our experiment, we are going to make this concoction, this pudding, without heating it. So I'm gonna need half a cup of sugar, white sugar to start with. There we go. Okay. I'm gonna need a 1/4 cup of my cornstarch. Kind of sticky. Right. I'm gonna need 3 heaping tablespoons of baking cocoa. Heaping means it's bigger than the spoon. See, it makes big. 2, 3, okay, and just a pinch of salt. So a literal pinch. All right, we're gonna whisk that together. Stir it up. It's all dry ingredients, so I'm just gonna use a whisk. You could use a spoon. Okay, that looks pretty good. Let's move on. Next, I need 2 3/4 cup of milk that I'm gonna stir in. This only does 1 cup at a time. So there's 1 cup. There's 2 cups. And then 3/4 cup. Okay. I don't know if that's gonna fit. It fit. Okay. A teaspoon of vanilla, which I have right here in my cap. Doesn't look like it's doing anything. Well, I want to stir it. I haven't added any heat, so it's not doing much. Okay. Does not look like pudding, I can tell you that. Okay, I've stirred this quite a bit and it's still kind of runny. I'm supposed to add this butter, but you know what? I don't think I'm gonna add the butter because it's just gonna go round and round in circles here. There's nothing to melt the butter. I mean, it looks good. Taste it. Tastes good. But that's not pudding, is it? That's too runny. Let's try that again, but this time we're gonna heat the concoction. We're gonna add heat to that cornstarch mixture to allow it to soak up more of this liquid because it's pretty runny right now. That's not pudding at all. Let's do it. Okay, this time I'm gonna take my 1/2 cup of sugar and I'm gonna put it in the saucepan that I'm gonna heat up later. Okay, I'm gonna add my 1/4 cup of cornstarch. Instead of the cocoa, that would have been a lot of chocolate. And that goes, whack that off of there. My pinch of salt, pinch, and my 3 heaping tablespoons of cocoa. 1, 2, 3. So you can see the ingredients are just the same. I have my powder again. Mix it up a little bit. But this time I'm going to put it on the stove before I add my liquid ingredients. Okay, next I'm going to add my 2 3/4 cups of milk. There's my 1 cup. And I've turned my burner on so that it will start to heat up here. 1, 2 3/4. Okay. Let's see what's going on here. I'm just gonna stir this. Right now it looks a lot like my other stuff looked, just kind of this big mucky muck mess. We're gonna bring this to a boil and then we're gonna see stuff happening. So let's wait for that to happen. All right, it's not hot yet. You can see at this point it looks a lot like the other stuff. Kind of runny. Tastes good. Tastes like chocolate milk, but it's not very thick. So we need to bring this to a boil. Okay, I've started heating this up. You can see that it's lost some of its bubbliness and it's now getting smoother like chocolate milk. There's some steam rising off it, so we're getting close to the boiling point. Have to keep stirring it because milk will scald on the bottom of the pan. Once it starts to boil, keep stirring it, let it boil for a bit, and it should start to thicken up. It feels like it's thickening now. I can tell I'm getting close. It's more like mud. It's working. Those little cornstarch molecules are starting to suck up more of that milk, make a thicker pudding. Oh yeah, it's starting to look like pudding now. As soon as that starts boiling, The recipe says that I'm supposed to put a metal spoon in there and see if it sticks to it. So we're not there yet. It's got to boil first. So I really, really need to bring it to a boil. Oh, I see little bubbles. Do you? Blurp, blurp, blurp. It does look like mud. Blurp. I'm going to stir this and cook it just a little bit longer. Give it a chance to really suck up that liquid to make a nice thick pudding. I'm going to give it the spoon test. Yep, it's stuck to my spoon. Okay, I've taken it off the heat. I've added my 2 tablespoons of butter and my vanilla. Butter melted in there, still kind of chunking around. Now I'm going to take some of this, it's still steaming. I'm going to pour it into a little pudding cup. Ugh, making a mess. There we go. I'm gonna let that cool a little bit. Go put it in the fridge. All right, I have the results from my experiment. This was the first one we did, the one we used a cornstarch. They both had cornstarch, but this one I did not heat. And you can see it's really liquidy. Probably tastes good though. Tastes like really chocolatey milk, which is kind of what it is. This one, same ingredients, although I did skip the butter on that one because that was going to be a wasted effort. Did add the butter, but other than that, this one I did heat up. And you can see that this one looks like pudding. Smells like pudding. And it tastes like pudding. Cornstarch thickened it up into pudding. You know, this would be really good with some of that homemade whipped cream that we made a few lessons back. Just saying. Anyway, go cornstarch. Without cornstarch, we wouldn't have delicious chocolate pudding. We'd have chocolate milk. More science experiments. For the next part of this lesson, we're going to make something called ooblek, which is something you play with, not necessarily something you eat. Now, the cool thing about ooblek is it's sort of a mystery substance. I mean, most things are either a solid, they keep their shape no matter what you put them in, or they're liquid, slosh, 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 or they're a gas. They're not like multiple, but ooblek is actually a solid and a liquid, depending on how you use it. To show you what I mean, let's make some. Now, you'll normally use cornstarch to make ooblek, but I kind of had a question, a scientific question. What happens if I used a different kind of starch? This is potato starch. This is cornstarch. Both are starches. How do the oobleks compare? Let's find out. I'm going to start off making some regular old cornstarch ooblek. Whenever you get a recipe off the internet or in a book, it's always cornstarch ooblek. I'm not sure why. I don't think a lot of people use potato starch for stuff, except on Passover, but cornstarch is readily available for most things, so I think more people have cornstarch. All right, I'm gonna add some water, a little bit of cold water here, and I'm gonna start to mix it until it just kind of mixes together. Now you'll notice as you start mixing it that it's getting kind of hard to mix. That's the whole point of ooblek. When you move fast, it turns into a solid. When you move slow, it turns into a liquid. I think I need a little bit more water. Okay. So you add enough water so that you kind of have this runny stuff going on. Gotta be patient with it. It's hard to stir it. That's ooblek for you. Now, just for funsies, I've got some food coloring here. I'm gonna drip it in there. Ooh, that's pretty. Check that out. Okay. I'm gonna mix that in there too, which presents yet another challenge because I can't mix anything with ooblek. Arg. All right. It's mixed up pretty well, and it's sloshing around like a liquid. When I try to pick it up, if I keep it moving, it turns into a solid. The minute I let it go, it turns into a liquid again. This is a little bit on the runny side. I should be able to keep that solid going a little bit more. I'm just gonna sprinkle it. A little bit more cornstarch on there. You really can't mess this up. Well, no, you can, I guess. Okay. You'll know it's right when you can actually pick it up. See? Now, when I keep it in motion and I apply kind of pressure to it, it's a solid. See? The minute I stop, it turns back into a liquid, which I can grab quickly and turns into a solid. This stuff is really cool. This is ooblek. Okay, I rinsed my hands. The cool thing about this, it's really easy to get off your fingers. Just add more water. It's more water than the cornstarch can hold. It just comes right off. So my next question as a scientist is ooblek, this amazing stuff, a property only of cornstarch, or can I recreate this with other kinds of starches? I have here some potato starch. So get rid of the cornstarch. Let's find out. Again, I'm gonna scoop some, this stuff, the particles are smaller. Woo, I don't like the way that feels at all. Ugh, kind of gives me the shivers. All right, I'm gonna do that. Ugh. I'm gonna add some water, just like before. This stuff is a milkier color. I am gonna color it, but I wanted to do this first without the colors in it. Okay. It looks a little bit different than the other stuff did. Let's add some red coloring. See what happens. Ha, that does look cool. Mix that up. It's very hard to stir this, just like the cornstarch. Okay, I have here the two oobleks. This was the one from the cornstarch. And like ooblek, now I'm going to dump this onto the plate. Okay, I have here my two oobleks. They behave in the same manner. If I hit it, it's really hard. But if I put my finger in slowly, it sinks in. I can gather them both up into, oops, I just ripped my paper, solids. This one feels smoother. The potato starch feels silkier. The particles are smaller, but it behaves the same way. The cornstarch one, I don't know, it feels a little bit different, chunkier, I guess. Don't worry about the different colors. That's just the way it works. I don't think I added the same amount of food coloring. So what did we learn from this? That ooblek made from potato starch and ooblek made from cornstarch behave in the same way. So if you don't have any cornstarch, go ahead and use potato starch. If you don't have any potato starch, go ahead and use some cornstarch. Either way, making and playing with ooblek is really cool. Well, that's all I have this week on starches, a totally awesome thickening agent. Have fun playing with your ooblek, and I hope you get to make some of that pudding. It was very delicious. As I stated before, this is the end of the kitchen chemistry unit. We've got lots of other science things to learn about. It's going to be awesome. Kitchen chemistry was pretty cool, and science is cool.